In the regions of smaller input currents, the output is much smaller than it would be, and this is called crossover. This region where the the sinusoidal current becomes zero, so that effect is called as crossover distortion. Actually, in one point it will be zero, right? One point only a sine wave will be zero, but in the output you see, for a continuously from 0 to zero point 0.7 it is zero, and same way when it is reducing from 0.7 to 0, again it will be zero. So this effect is called as crossover distortion. So how to overcome this crossover distortion is this crossover distortion will result in a period where both the transistors will be off. I told you already, right? When one transistor is conducting, other will be off. When the first transistor is off, second will be conducting. That is the sequence of class B amplifier, right? But because of crossover distortion, there is a chance that there is a brief period of time where both the transistors are turned off. So Q1 is on, Q2 is off, Q1 is also off for some time, then Q2 becomes on. So there is one point of time where both the transistors are turned off because of crossover distortion, and it occurs during the time when one transistor is going to off state, other transistor is going to on state. You see, ideally the sine wave should start from this vertical line, but it is starting after some time delay because of crossover distortion. This is the positive half cycle. This is the negative half cycle. So when you combine both, you can see there is a brief period of time where the output is staying zero in both the cases. When you join these two waveforms, you can see this portion you have a crossover distortion. In this portion you have crossover distortion. In this portion you have crossover distortion. Even in the starting also you have crossover distortion. Here also you have crossover distortion. Wherever your sine wave is reaching zero, at all the points you will have crossover distortion, because ideally sine wave reaches zero only at one point, but because of crossover distortion there is a brief number of points where the sine wave becomes zero. This is because of the inherent property of cut-in voltage of your transistor. So how to minimize crossover distortion? You have to operate the device in a class AB mode where some small current is always flowing, which will ensure that only after the second transistor is perfectly on, the first transistor is made off. Okay, you're able to understand. See, in this region, both the transistors are off, which is a drawback for me, because only when Q1 is completely turned off, Q2 can turn on, right? So at this point, both are off. So which will lead to distortion in my circuit. So what is the only option? You operate the device in a class AB mode. AB means there will be some definite amount of current flowing through your circuit, which will ensure that only when one transistor is off perfectly, the other transistor will be on. Otherwise, the distortion is going to be minimized. But because of permanently having a current flowing through transistor, you will have loss of power, and also the efficiency will be slightly reduced. But if you want to avoid this distortion, only you have to go for that method. So one method is operating the device in a class AB mode. AB means it is not operating fully, it is not operating 50%, it is between 50 and 100%. So if you operate the device between 50% and 100%, you will definitely overcome this problem of crossover distortion.